Have you ever pulled up your security logs knowing the clues are in there somewhere, but the data feels too big, too noisy, and too slow to sift through when time matters most? In a real incident, the difference between we think it's fine and we can prove that what happened often comes down to how quickly you can ask the right question of your data. In this session, you'll learn how to turn that flood of telemetry into clear answers using the Kusto Query Language, or KQL, in Microsoft Sentinel. Hello and welcome. We're glad you could join us. I'm Jean-François Bilodeau, a Microsoft technical trainer. In this session, we'll cover creating queries for Microsoft Sentinel using the Kusto Query Language, also known as KQL. Together, we'll build a strong foundation of how KQL statements are structured, how data flows through a query, and how to apply the important operators to your search, filter, shape, and analyze the result. You'll also see how to combine data from multiple tables and how to extract value from both structured and unstructured string field, aka text field. Skills you'll use constantly when hunting threats and investigating incidents in Microsoft Sentinel. So let's get started with this session. Here we set the stage for the broader mission, defending against cyber threats using Microsoft Security Operations Platform. As you work through this learning path, keep that goal in mind, helping a security operation team detect, investigate, and respond effectively. Let's take a look at where we are in the course. This is Learning Path 6. Focus on creating queries from Microsoft Sentinel using the Kusto Query Language, or KQL. Here's your roadmap for this session. We'll start by constructing KQL statements from Microsoft Sentinel, then move into analyzing query result using KQL. Next, we'll build multi-table statement using KQL so you can combine data set when a single table isn't enough. And we'll wrap things up by working with string data, also known as text, in KQL statement, including extracting and shaping text and JSON-like content. As we go, expect a lot of hands-on querying. The intent is to demonstrate each KQL example, often by typing the KQL rather than relying on copy and paste, except for larger sample. You'll also notice the learning flow emphasizes practice. That repetition is what helps KQL become natural in real investigation. Now we begin our first module, constructing KQL statement for Microsoft Sentinel. This is where you learn the core building blocks, how to write queries that are readable, repeatable, and effective when you're under pressure. By the end of this module, you'll be able to do three things. First, you'll construct KQL statement using the standard pattern that Sentinel and Log Analytics expects. Second, you'll use KQL to search log files for security event so you can find the signals in the noise. And third, you'll filter searches based on meaningful investigation criteria like event time, severity, domain, and any other relevant field so you can narrow quickly from everything down to this matters. KQL query are read-only requests. You're asking the system to process data and return a result, not to modify the underlying data. The language is written as plain text and follows a data flow model that is designed to be easy to read, write, and automate. In practice, you'll build a query that starts with a data set, usually a table, and then you stream that data set through a sequence of operators. It also helps to remember the schema organization. KQL works with entities arranged in a hierarchy similar to SQL database. Tables and columns. The most important mental model, though, is the pipe. Everything to the left of a pipe symbol is processed first, and the result then flows to the right into the next operator. If you understand that flow, you can read almost any query like a story. Start here, refine this, compute that, and then return the final shape of the result. During demonstration, you'll typically begin by accessing a log analytic demo environment and working directly in the query window. And if you want additional support as you practice, Microsoft provides a KQL quick reference and a set of query best practices in the Azure Data Explorer documentation. Let's start with the simplest way to query, referencing a table. In Sentinel, you'll commonly work with tables like security events, security alerts. Most of what you write will be a tabular expression, columns and rows. Statements, meaning the input is a table and the output is also a table. When you chain operators together using pipes, passing the tabular result from one step to the next. At the most basic level, you could run a query by entering only the table name, but that approach is usually inefficient because you'll pull back far more data than you need. The real power comes from immediately shaping and filtering what you retrieve. When you need to quickly hunt for a term across data, the search operator is a fast way to begin. For example, you might use something as simple as search new to find records containing that word. You can also scope the search to specific table, like searching within security event and any table that starts with app by using the patterns such as search event app, new. This is especially useful early in an investigation where you're still figuring out where the relevant evidence might live. Most investigations rely heavily on the where operator because filtering is how you get from broad telemetry down to events that matters. A common first filter is time. For example, starting with security event and then narrowing to event where time generated is within the last hour using time generated greater than ago, 1H, as in 1 hour. From there, you can combine condition into a single step, such as filtering the last hour and also matching an event ID, like event ID equal, double quote, 4624 for logon events. You can also express the same logic as multiple where steps, which can be easier to read. First filter by time, then by event ID, then maybe by account type. For example, using the case-insensitive equality operator, the equal till, with a value like user. And when you want to match several event ID, you can use in, such as filtering where event ID in, and then specify the event ID 4624, 4625 as an example, put them in bracket for successful and failed login. Using the let statement, as your query grows, you'll want them to be easier to read and maintain. And that's where the let statement comes into play. With let, you can declare variables and reuse them. For example, you might define time offset equals 1H, 1 hour, and discard event ID equals 4688, then filter security event to a specific window. Events between time ago, time offset times 2, so 2 hours, and ago time offset also excludes a noisy event ID by checking that this event ID exclamation mark equal discarded event ID, so not equal event discarded event ID. You can also use let to define a reusable data set. For example, you could build a table called low activity accounts by summarizing counts by account and then keeping only accounts with fewer than 1,000 events. After that, you can refer reference the low activity account like any other table and further filter, such as finding account where the name contains the string SQL. This pattern helps you declare and reuse variables and also declare dynamic table or list that can simplify complex hunting logic. Next, let's create new fields on the fly with the extend operator. Extend adds calculated column to a result, which is incredibly useful when you need to derive a value that doesn't exist directly in the data. For example, is starting with security events, filtering on the last hour and ensuring both process name and process aren't empty. From there, you can compute a new column called start dir by using the substring function and string size function to strip the process name down to just the starting directory portion. Another powerful pattern is normalizing value into a sortable order. For example, using security alert over the last 7 days, you can extend a new column called severity order using the case function. Mapping high to 3, medium to 2, low to 1, and informational to 0. And using -1 as a default, for example, for missing values. This makes it much easier to sort, group, or threshold alert consistently in later steps in the demo. Once you filter and enrich your data set, you often need to sort it to spot patterns. The order by operator does exactly that. Building on the previous example where we computed start dir, you can order the result with start dir descending, DESC, and then process ascending, ASC. Sorting like this can quickly reveal unusual directories, rare processes, or anything that stands out once the noise has been reduced. Another essential set of tools is the project family of operator, which controls the shape of your output. With project, you choose which column is included in the output, and you can rename, drop, or insert newly computed columns. If you want to exclude certain column, you can use project await. If you want to keep only specific column, use project keep. To rename fields cleanly, use project rename. And if you want to just reorder the columns in the output, use project reorder. For example, you might start a security event and simply project computer and account to focus your view. Or you can take a longer query filtering by time, ensuring process fields are present, extending start dir, sorting the result, and then finish by removing a verbose column like process name using project await. This is a great habit for making your results easier to read and easier to share with your teammate. With the fundamentals in place, let's move into analyzing query results with KQL. This is where KQL becomes more than find events. It's a way to summarize what's happening and communicate it clearly. After completing this module, you'll be able to summarize data using KQL statement and render visualization using KQL statement. These capabilities help you answer high-level questions like, how often is this happening? Who is most impacted? And is the situation getting better or is it getting worse over time? The summarize operator is the heart of analysis in KQL. It groups records and calculates aggregates so you can understand patterns at scale. Common functions include count, count if, to count records, decount, and decount if to estimate distinct value. We've got average and average if for average, max and max if for maximums, sum, and sum if for total value. For a quick example, you could take security events from the last hour and summarize the number of distinct IP addresses using summarize distinct IP. In a more investigation-focused scenario, you might define a time frame, like 30 days, and a threshold, then query sign-in logs for sign-in attempts where the result description contains invalid password. From there, you can summarize the distinct number of applications being targeted by counting distinct app display name value per user principal name and IP addresses. And finally, filter to case where the application count meets or exceeds your threshold. This kind of query helps highlight suspicious patterns such as password spray activity across many apps. Beyond counting and distinct values, Summarize can help you filter by keeping only the most relevant record in each group. Two key functions here are argmax, argmin. For example, if you filter security events to a specific host like sql10.na.contosohotel.com, you can use summarize argmax time generated, star by computer to keep the most recent records by computers. Or you can use argmin time generated star by computers to keep only the earliest record. Sometimes the goal isn't just to calculate a number. It's to prepare unstructured output so you can reuse or pivot on. Two functions that help are make list and make set. For example, you might query security event for the last hour, filter to successful logon with event ID equal 4624, and then summarize make list account by computer to create a list of accounts seen on each host. If you want unique values only, you can use make set account instead. Once your data is summarized, you can turn it into visual using the render operator. Common visualization includes area chart, pie chart, column chart, scatter chart, time chart. For example, you can take the security events over the last hour, summarize count by account, and then render a bar chart to see which account appears more frequently. Or you can summarize count over time using a bin, such as bin time generated, 1M, meaning 1 minute, and then render a time chart to visualize activity trend minute by minute. Now let's move beyond single table query and focus on building multi-table statement using KQL. In a real Sentinel investigation, the story is often spread across multiple data sources. So you need to merge and correlate table to see the full picture. After completing this module, you'll be able to create query using unions to merge results from multiple tables, and you'll be able to merge two tables with the join operator. These two techniques, using a union and join, are foundational for correlating activities across identity logs, endpoint events, alerts, and application telemetry. The union operator lets you combine rows from multiple tables into a single unified result set. As a simple example is security event, union, sign-in log, which pulls events from both sources into one stream, so you can continue to process. Once you've unioned tables, you can summarize across the combined data set. For instance, running summarize count and then projecting that count into a clean output column. You can also union in more advanced way, like unioning a base table with the summarized output of another query in parentheses. For example, unioning security event with a summarized count from sign-in log. Another common technique is using wildcard, such as union app star, and then summarizing count by type to understand how many records are coming in from each matching table. While union stacks a result, join correlates them. The join operator combines record from two datasets based on a matching key, such as account name in a device name, a session identifier. In this example, we start with security event, filter to logon event, for example, where event ID is 4624, then summarize a logon count by account and project logon count and account. Next, we join using kind equals inner with a second data set built from logoff event, where event ID equals 4634, summarizing a logoff count by account and projecting the same key. Joining one account gives a combined view where you can compare logons and logoff side by side. When you join table, the specific join kind, sometimes called join flavor, determines which record are kept on the left side, the right side, or both. It's essential to understand the impact of that choice. With some join kinds, you'll keep only the matches with the other. You'll preserve unmatched record from one side. As you build correlated query for investigation, always pause and confirm. What should happen to records that don't have a match? That's one decision that can completely change the conclusion you draw from the data. Next, we'll focus on working with string data, also known as text, plain text, using KQL statements. Security data often contains key information embedded inside text, things like command line, accounts, strings, JSON blob, and even event message. So being able to extract and transform text is a major advantage in hunting and incident response. After completing this module, you'll be able to extract data from unstructured field, extract data from structured string data, and create functions using KQL. These skills help you turn messy text into clean field you can filter, summarize, and join, just like any other columns. To pull value out of unstructured text, KQL provides the extract function, which uses regular expression. A simple illustration is printing the result of the example we have on screen and confirming it returns 45.6. That pattern defines a regex, a regular expression. Choose a capture group, the brackets, and apply it to a string. Scale directly into real security data. For example, you might query security event for a privileged activity event like event ID 4672 and focus on record where account type equals user. From there, you can create a normalized account field by extending a new column such as account name and using the extract function with a regex designed to pull just the username portion from different account format, converting the input to lowercase for consistency. Once the account name is extracted, you can summarize a login count by account name, exclude empty result, and then filter to account with fewer than, say, 10 logins. An approach that can help highlight rare privileged login worth investigating. Another approach for unstructured string is the parse function, which is great when the text follows a consistent pattern. In this example, we create a small data table called traces with a column named event text, containing a structured message like event, notify, slice, release, as we see on screen over here. When we parse event text, mapping part of the string into name field like resource name, total slice as a long, slice number as a long, which is a 64-bit value, and timestamp such as log time, release time as a date, and previous log time as a date. After parsing, we project those extracted fields so the output becomes a clean table you can analyze. Now let's take a look at structured string data, especially dynamic fields and JSON. In sign-in logs, some properties are already available as dynamic object. So you can extend fields directly. For example, you can extend a new column OS from the device detail columns, device detail.operating system, to quickly analyze sign-in by operating system. When JSON is stored as a string, you can convert it into a dynamic object using parse JSON. For instance, you might extend the auth detail by parsing the authentication detail field, then extracting value from the first elements, like auth method from auth detail 0, authentication method, and auth result from a nested field, such as auth detail 0, the first one, and then the field name authentication step result detail. Finally, you can project auth method, auth result, and default auth detail object to validate your parsing. In some scenarios, you'll want to enrich your query with external data, like a watch list of user ID, hashes, or known indicators stored outside Sentinel. KQL supports this with the external data capability. For example, you might query a user table and filter where user ID is in a list returned by your external data user ID string. Pulling value from a text file hosted in an Azure blob storage, in practice, access to that blob typically requires a secret token, such as a SAS token, so always plan for secure access control when integrating external sources. To make your KQL reusable, you can save queries as functions, especially useful for parsers and common investigation pattern. For example, you might start from security event, filter by event ID equals 4672, and account type equals user, and then save the query as a function named privilege login. After it's saved, you can invoke it by simply calling priv logins, just like you would reference a table. Now, it's time to bring everything together in a focused demonstration. Here we'll create and run KQL query in Microsoft Sentinel, applying the patterns we've seen so far. In this demo, let's take a look at Log Analytic Workspace, how to query with KQL through our Defender workspace. First thing I'll do here is crack open Microsoft Sentinel. Open our workspace, and under Log, enter the Query Hub. So let's select Sentinel. Let's go into Logs. Let's close the Query Hub. This is useful to get started, but we're going to get started raw. This brings us to the query history in simple mode. Let's switch to KQL mode. KQL mode will allow us to write raw KQL query. Great for learning, great for understanding. It's also, in my opinion, the fastest way to write query. On the left over here, we can select tables we'd like to query. But in our case, I'll just start typing the name of the table I want to query. Let's go with security events. This is about the simplest query you can create. Type in the name of a table, hit the run button, boom, here's a list of results for you. We're seeing all the rows in our security event CL table. Actually, we're not seeing all the rows because there are filters at the top. We can see we're only showing the first 1,000 result and the last 24 hours as well. If necessary, we can change the time range or choose the number of results that show up. We can do that either through the toolbar, or we can do it directly inside the query interface, which we'll see later on. Another way that we can start a query in KQL is by doing a search. Let me give you an example over here. Search computer. What this does over here is that we'll take a look at every table and every entry and pull up results that have the word computer in them. Here we go. Notice the $ table in the columns over here. That tells me which table the results come from. Some come from the office activity, other from security event. We can see why those rows were included. They have the word computer in them under the account. When it comes to the one for office activity, it would be somewhere else in the entry. Well, let's take a look at a variant on the search. We're going to say now search in security event and any table that begins with app star. And we're going to look for the word new this time. Let's run the query. And here's our results. Again, same principle. Because it's a search, it's going to bring up a variety of tables. Look at all tables that we've selected. We can see which table the results we're seeing over here come from using the $ table column. Now let's start adding some filter. We know that we can filter using time range at the top over here, but let's filter right in the query. Very useful, especially if you're going to save queries and reuse them. So we're going to search query security event, but now we're going to add a predicate where time generated greater than ago 7 days. So let's go back 1 week. So from now to 1 week ago. Notice because we are now adding a predicate based on time generated, time range now says set in query. Here are the results. So now we are seeing the last 7 days of activity in security event CL. We can filter further. For example, in the table, we have an event ID column. Let's filter by that one. I'll add an AND clause over here and event ID. And we're going to put in to equals, and let's go with 4624. Run that. And now we're looking at the last 7 days of events and only event IDs that are 4624. To make it easier to read, let me put that on 2 separate rows. So we'll have one row to filter the duration, another row to filter by event ID. Makes it a little bit easier to read. We're going to add another where clause over here where we're going to search by account type. And let me use a different operator this time. I'll use the equal tilde and the word user. The equal tilde does a case insensitive search. Notice over here how the word user has a capital U, but in the query, I wrote it with a lowercase u. So that's a good operator to know. It's an operator you'll see very often in sample KQL queries. Another useful operator I'd like to introduce you to is the in operator. What if I'd like to look at multiple event ID, not just 4624, but say 4625 as well? Let me use the in operator where event ID in, and inside bracket, let me put in all the values I'd like to use, 4624, 4625. There we go. Now we've got both event IDs coming up in the result. We could also negate the condition by saying where event ID not in and provide a list of events. Now, as our queries get more sophisticated, we'll want to make it easier for us to make changes to values we provide in here. And I'd like to explore with you how to use variables in your query. Here's a quick example for you. Let me drop that in here. And notice in this query, we're adding two let statement. Let time offset equals 10 minutes. Let discarded event ID equals 4688. And following that, we are querying our security event CL table. But what's different now is where we have our condition, like where time generated greater than ago time offset. Time offset is our variable we've defined. That's a name that we've chosen to represent 10 minutes. There it is. So we don't have to repeat it. We are creating a 1 minute window, 10 and 11 minutes over here. So we don't have to repeat 10 minutes. And furthermore, if we want to change it, there's only one place where we need to go now, the variable. Let's run the query and see that, well, the same will apply to discarded event IDs. Discarded event IDs now at the top, making it easy to change. There we go. Here's the result of our query. Time generated, we're looking at just 1 minute, 10 minutes ago, 11 minutes ago. And the event ID, we should see every event ID except 4688. We're using the exclamation mark equal over here, not equal. So give me everything except 4688. So this gives us a convenient way to improve the readability of our query, make it easier to change our query, avoid duplication when we modify the query, when we write the query. Let's continue our exploration of KQL. Now let's take a look at how to summarize and aggregate result in our query. Instead of seeing individual rows, I'd like to see aggregates of that rows. So we're going to start with our same table, security event. We're going to clamp it to 7 days, a week, and event ID 4688. But notice the next line now. We're adding the summarize operation. Summarize count by computer. So what I'd like to know over here is in our security event, how many times has a computer showed up in here? Let's run the query. There's our result. We can see over here which computer shows up more often, less often, based on the count by computer that we have over here. We can see the victim PC console. So Azure has a lot of activity, giving us a sense that, hey, maybe we'll want to take a look at this machine. Notice as well how count is spelled with an underscore over here. We can change the name of the column. For example, I'll use CNT. I cannot use the word count because that's a built-in word, but let me say CNT equals count by account type. And notice that the count column is now simply known as CNT, or any other name I would have chose to select. So there's the account type, the computer, and the count of events. So now we're looking at the account type, the computer, and how many times does that combination come up in the last 7 days. So user at victim PC shows up 10 times. Here's a variant for you. Let's explore a new query with signing logs where time generated is 1 week ago. But now we're going to summarize not by count, but by decount, distinct count. I want to know how many distinct IP addresses do I have. And in this case, in my sign-in logs, I can see that only one IP address is used. That's what the one represents over here. If I saw two, that would mean there's two different IP addresses that shows up in that log. Let's continue to refine this. Here's a slightly more sophisticated query over here. We're still going to use decount, and we're going to use variables at the top, going back, in this case, 30 days. We're going to look for a result description. The result description column that has the text user account is disabled anywhere in the column. And now we're going to summarize using the count over here. We're going to name the column application count equals the count app display name. So let's display the number of times a specific application name shows up. And we're also going to group that by user principal name and by IP address. And then we're going to add a filter to the result. What we care about is any application count whose name shows up one or more times. And there go, in this case, there's only one. We can see that John, with their IP address, has one application showing up in here. John's entry with that specific address may actually show up multiple times in the logs, but because we're using dcount, it shows us that this specific combination exists only once, shows up only once in our log. Last example I'd like to give you over here. Let's talk about make list and make set. They may seem intimidating at first, but I highly recommend play around with them. Make sure you're familiar with them. Here's an example, security event CL. Again, we're going to go back 7 days. We're going to look at event ID 4624, but now summarized by make list. So we're going to create a little table, a subtable over here, make list account as by computer. So we can see over here a list of computer, and beside that, we have a list of all accounts that were found on that computer. We can expand those list account to see which accounts are used by this computer. So this is a table within a table. We're creating a list of accounts. Duplicate accounts will show up multiple times in the table. Let's expand it. And notice how we can see the same account more than once in the list. Let's crack that open again. And notice Contoso Azure AATP service shows up a couple of times. That's make list. Make list does not remove duplicate. It shows us all individual value. But what if I don't care about the duplicate? I just want to know if that account is present on that system. I want to get rid of duplicate. Well, let's make one quick change to our query. Let's use make set instead of make list. Same thing, but the difference now is all duplicates will be removed. Let's crack open our victim PC. Let's take a look at the account and notice now how Contoso Azure AATP service shows up only once, even though we know that it's there multiple times in the table. So make list, show me all the individual values. Make set, show me only distinct values. For our last set of KQL demo, let's get into something a little bit fun. Let's get into visual. We'll start with our security events. We've seen that a couple of times. We're going to filter by the last 7 days. There's the result. Nothing really new. But what I'd like to do next is let's summarize count by account. So let's see which accounts were used in the last 7 days. Here's the result. But what I'm seeing over here is the name of an account and the number of times they're used. I'm going to change the sort over here, order by count, going descending, the account that has the most activity down to the one that has the least activity. Administrator is at the top, which is always a bit concerning. But what I'd like to do over here is to make it easier for me to read and evaluate, understand what's happening over here, especially in terms of ratio. Let's generate a visual. Let's render a bar chart. Let me add over here at the end, render bar chart. And there we go. KQL now generates a bar chart for us. Much nicer visual, allowing me to get a good sense as to really how much more the administrator account is being used. And if I'd like to look at it more from a ratio side, how about we render a pie chart instead? And there we go. Here's our pie chart. Again, administrator represents 42.97% of all account activity. Not too surprising, but maybe a bit concerning. Either there's privilege, abuse, or maybe something else is happening. But one way or another, we've seen over here how to generate visual using KQL. Let's recap what you've accomplished in this learning path. You've learned how to construct KQL statement from Microsoft Sentinel, building queries that follows the data flow model. You practice key KQL operators like summarize, render, union, join, and extend to filter, shape, analyze, and visualize your result. You also learn how to extract data from unstructured and structured text field, which is critical for working with real-world security telemetry. And finally, you saw how to create functions and parser using KQL so your best queries can be reused. As we close out, take a moment to reflect on the key outcome. You now have practical KQL skill. You can apply immediately in Microsoft Sentinel. Whether you're hunting, triaging alerts, or investigating an incident, the more you practice writing queries and reading the pipeline from left to right, the faster you'll be able to move from raw logs with confident solution. This concludes our session. There are many more ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.